All right, in this video, we're going to be focusing mostly on finding increasing, decreasing, and constant intervals within a function, as well as finding the local and absolute extrema of a function. Okay. Now, if you are presented with the graph of a function, you're going to want to read that graph like you read a book, which would be from left to right. Okay, from left to right. So we have a concept from there of a function being increasing, being decreasing, or being constant. So we would say that the function is increasing on any interval when the y values increase as the x values increase. So that means as you move from left to right on the graph, as your x values are increasing, your y values, if they are increasing, the function is said to be increasing. Okay, so if you look at the graph that's pictured here, notice the sections that are in green. Okay, those are their y values are getting larger as you move from left to right. So we would call those increasing intervals. Okay, so the first increasing interval would be, we would write these in terms of x value. So it starts right here and ends right here. And we're going to say that that's the interval from -1 to 0. Okay. Now the next increasing interval definitely starts right here. And then some of you are going to argue that it ends here and then picks back up, but that entire section is green, right? All the way up to here even. Okay, so even though we're increasing at different rates, we're still increasing the entire time as we move from left to right. So if we assume that that graph continues in an upward trend, we can say that it also is increasing from the x value of +1 to infinity. Okay. So even though those look like two separate intervals because they're like two separate pieces of the graph, um, they're both increasing, so you put them together as one interval. Okay. Now your function's decreasing over an interval when your y values decrease as your x values increase. So that means as you move from left to right, your y values are getting smaller. Okay. In this graph, that would be the red section there. And that's beginning at this point and then ending right here. So in terms of x values, we would say the function's decreasing from 0 to 1. Okay. And lastly, your function's constant when your y values remain the same as your x values are increasing. So your y values are constantly the same number. Graphically, that just means any section of the graph where you are a horizontal line. Okay, so in this case, let's consider this to have an arrow at the end there. That would mean we're constant from -infinity all the way up to right here, which would be -1 as an x value. Okay. Notice on each of these intervals, doesn't matter if I'm increasing, decreasing, or constant, I'm just using parentheses to open and close the intervals. I don't use brackets. Okay. All right, moving on to local and absolute extrema. Okay. We have concepts of local maximums and local minimums, and there's some really fancy definitions to go along with them, but I think you can graphically visualize them very easily. Okay, so if you look at the picture here, this is considered a local maximum. Okay, it's not the absolute or global maximum of this function, meaning it's not the highest point of the entire graph. But if you're focusing on just this small localized section of the graph, it is the highest point, okay? Now notice the definition for a local maximum, and this is really important. If a function changes from increasing to decreasing at some point AB on your function, we say that the function has a local maximum of B at x equals A. So we're saying that to be considered a local maximum, the graph has to go from increasing, so right here it's increasing, to decreasing, okay? Now, similarly, we have a concept of a local minimum. Right here is a local minimum. That's because it's the lowest point in this small localized area, okay? And same kind of definition, except it just switches. If a function changes from decreasing to increasing at some point AB on your function, we say that the local minimum is B at x equals A. So in this picture, we are decreasing, and then at that point, we turn back to increasing. So there's our local minimum at that point, okay? Now, in terms of absolute or global maximums and minimums, you have a global or absolute maximum at the highest point of the function over its entire domain. So right here, based on what we can see for this graph, that's the highest point for the entire graph, right? So that's our global or absolute maximum. And then right here is the lowest point of the entire graph. So that is our global or absolute minimum. All right, now let's look at our example down below. Here, more than anything, I want you to focus on the notation that I use, okay? So absolute maximum is, again, occurring at the highest point of the entire curve, the highest point of the entire curve. That would be right here. So how are we going to write that? We're going to say that this is an absolute maximum of 39 at x equals -2. So it's the y value that's considered the absolute maximum, the 39, and we're just saying where it's located at by listing the x value, okay? Absolute minimum would be the lowest point of the entire curve, which is right here. I would say my absolute minimum is -42 at an x value of -5. Okay? All right, local minimum. Remember, it's any spot on the curve where we change from decreasing to increasing, okay? And you don't list your absolute maximums and minimums when you give your local maximums and minimums, okay? So in this particular graph, the only local minimum we have is right here, okay? Right, we're decreasing on this side, and then at that point, we change over to increasing, okay? So I'm going to say I have a local minimum of 7 at x equals 2, okay? And lastly, you can see there is no local maximum I've listed. And some of you might argue that right here could be considered a local maximum. However, we're considering that to be an endpoint of the graph, okay? And this is where the definition of a local maximum really comes into play. On one side of the local maximum, on the left side, the curve needs to be increasing, and then on the right side, the curve would need to be decreasing. Well, if that's an endpoint right there at 314, there is no right side beyond that point for us to consider to be decreasing. So therefore, we can't call it a local maximum. Now, if the curve did something like this after 314, if it went, back down, then we could call that a local maximum of 14 at x equals 3. Okay? All right, now it's your turn to practice. Giving you a graph here. You are going to use it to identify all the different intervals and extrema here. Extrema is just a generalized term for local maximums and minimums, absolute maximums and minimums. Okay, so work through this yourself as you pause the video, and then you can come back and check your work with mine.